Hey, here we are on a GitHub Codespace environment. Basically, this is your GitHub repo where we are trying to spin up a K8s cluster on demand. So, what does this repo has to offer? It's basically a instant three-node K3d cluster. This particular template, and then there is one with Minikube. We will get to Minikube later on, but with first get at K3d cluster on demand. What is that it has to offer? It has to offer a three-node K3d cluster, a gateway API, and a GUI based out of Headlamp, right? So the gateway API, it already comes with all the CRDs installed and a Traefik controller, gateway controller, and it is optimized to run on your GitHub Codespace. So what does that mean? It means that on one click of this button, that is open in GitHub Codespace, and it should spin up within minutes, right? Within minutes, it need to spin up a K8s cluster. It will be three node, and let's see like how it goes. So this is what basically the intro of this particular public template is. So let me first click this, and then while it try to spin up, it may take some less than 5 minutes or so, hoping so. And meanwhile that it loads, I'll try to give you a brief code walkthrough of what has went into the secret sauce of getting this repo created, right? So in order to work with this cluster, right, any developer who wants to have a K3d cluster in the Codespace environment has to just come over to this repo and click on open in GitHub Codespace. It should take you to one more window where it says would you try to want to create a new Codespace for this, or you can customize the options of going with 4 GB RAM and then 4 core and then higher GBs of RAM. But then that is not required. Whatever the free tier that it has to offer with a minimal setting that it is 2 core and around 8 GB of RAM, so that should be sufficient for this particular template. So soon after, once you click this, then you go ahead and then say create a new Codespace, then it should start. So it says that setting up a new Codespace for you, it gives this particular random URL where this will be a particular domain name that GitHub Codespace has given to you. And watch over this building Codespace. So this is where the environment is being set up. What is being set up is something which I'm gonna walk you through this tutorials or video, let's say, right? So let's go to this. So while this guy spins up, let's head back and see what is happening. So on the startup, right? So whatever that you are trying to see over here, that has been scripted in dev container. So if you get into dev container, there is something called as dev container JSON. This is like beginning of what IAC that will be read by your Codespace engine to set up an environment for you. So what does it do? It takes up a Ubuntu base image and try to add in features like Docker in Docker with version latest, and have a kubectl, Helm, and Minikube. And Minikube, I have deliberately set it to none because we are trying to do K3d here, right? So we need to bring in the K3ds. We need to bring in the binary of K3d, not of Minikube. So I have made it none so that the Minikube doesn't get installed by default. So what we are trying to do on a base Ubuntu image, we are trying to bring in a DID, that is Docker in Docker, and kubectl and Helm pre-configured. That would serve as your base image. That is, you see this, it is trying to install kubectl and Helm and Minikube right now. So let's give it a time. Meanwhile, we'll go through this. Then later on create of this. So as I told before, since we have like, what do you say? So we have made Minikube none. So since we are trying to bring up a K3d, which is a lighter version, right? So of K8s. So we have to install that binary. So that's what we are trying to do. We are on create command. So we are trying to do a curl into this particular kind of open repo, which is K3d's binary, and trying to install that on create command. Once the K3d is installed, we go to something called as a post create command, where we will in short a while. So this is something which is sitting in again in dev container in init cluster UI, you see this batch script. So it is sitting over there. We'll see what it basically does. So before getting into post create command, all that we are trying to do quickly is that we are trying to open up couple of ports. One is 8080, another one is 9090. So 8080 is required for your all apps. Let's say you have deployed one of your app inside this K3d cluster. So now that need to be talking to the binary. I mean, basically the traffic need to be flowing into this particular cluster, and then it need to be out of this cluster, right? So that port is again 8080, and 9090 is for that GUI interface where you get a nice breathing pods. You could see the status if you are like me, if you are a kind of a visual guy, so you get to see that GUI, nice little GUI there. So we have forwarded 2 little ports over there, and then we are trying to make a customization on top of it, saying that I need 2 tools. One is VS Code YAML to detect YAML syntax. Another one is just kind of an IAC. I mean, we most probably, since we have this 9090 port with GUI enabled, this would be little less used. So this does take care of all the jobs that we are trying to handle, right? So yeah, this is pretty much what happens in dev container. Let's check the status before we get into init cluster. Let's see like whether it has spun up completely. Yep, see, you see this. So right now, I think it almost, it almost done with its work. If you see this, so you see this is the last script. We'll come to this. So this is literally how much that it takes to spin up a cluster. So it around 2-3 minutes it took. Let's see whether the user interface is ready, so that it gives you a gist of whether you see, if you head to ports, right? So if you go to this port and then click on user interface, browse button, open in browser button, let's see whether a GUI opens up or not, and see whether, and meanwhile, like that GUI, you see that headlamp getting spun up. So let's see this containers tab. So you see whether the container is really up or not. If you see, this is an integrated one, integrated into Visual Codespace. You see that there are containers. You see that since it is a K3 cluster, there are 3 little clusters that have been created. So since it is a Docker in Docker kind of a use case, where a server 0 is again a Docker container, agent 0 and agent 2 are worker nodes, which are again Docker containers, and a server LB, it's a load balancer for entire cluster, which is again a Docker. So you see that within your Docker, within your containers, three containers, a K8 cluster has been deployed within this. This is called as DID in short. So yeah, you see these 3 are already up and running. You see this, those are up. And then these are the images that have been used. And now let's go to UI, whether it is up or not. So you see that the headlamp UI with RBAC enabled, a cluster token you need to put in, which we will in a short we will understand why this RBAC is required and where can you find this. So yeah, so basically your K3d cluster is up and running, your GUI is configured, all right, and 8080 is ready for incoming traffic. So we'll go to this. So this is how quickly that you could spin up a multi-node, a true multi-node K3d cluster, which is light. So how it is light, I'll just give you a quick walkthrough. You see, if I do edge top, which you would see how much of a resource is being consumed. Let me pull this over here so that we'll always try to monitor this. So you see this on core 0 and core 1, what is the usage? You see almost, I mean, by my guesses, it tops to 30% max for kind of whatever the workload that I have on this. 30 to 40-50% is maximum that I have seen that it goes up, and the memory usage is around 3 to 4 GB at max. You see that now it is in an idle state. You see that it is consuming 2.5. So the basic tier at Codespace comes with a 2-core 8 GB RAM. So you see that only around 25% of it is being consumed right now. So yeah, this is over here. You can find out, you can see that there is a token that has been generated. Either you can copy paste it from here and enter into the GUI, or you can see that it has created a text file. You can just take it, copy this up, and then paste it here. So that's all. So This is basically a role-based access control for entire cluster wise. It has nothing to do with the GUI, just that a service account and a binding has been created cluster wide, all this cluster wise. And then you take that token which is generated by the cluster itself, you take the private token of it and then put it onto the cluster, so that your GUI cluster have a access throughout your kind of containers, right? So all the containers or basically entire cluster, so that it can monitor your CPU usage, memory usage, pods, what are the things that you create. So this typical headlamp setup, I would say. So yeah, so you could see that you have logged into the cluster clearly, and we will get into this. So we will get into this. This is how you log into a cluster basically. So let's come back and see what was there as part of post create command, right? So you saw, I mean, you could guess, you could clearly guess that a K3d binary has been installed. What do we need to do? So we need to basically, in a post create command, we need to go ahead and then create a cluster, number one. Second, install a UI and create a role-based access RBAC token. So that is what we will typically do in init the cluster with UI. So let's get to that. So init cluster UI. So what's happening here? It's a typical your batch SS, right? So here, so we are trying to create a cluster. If the cluster exists, then ignore, then echo that the cluster is created, then skip the creation process altogether. Otherwise, go ahead and create. So how do we do it? It has been automated. So here, a typical K3d cluster create command with a pre-initial, I have given my username as cluster name. So you could see that the same username, you see this Wins code cluster, that's the similar name that has been picked up from this variable. And then it refers to something called as a K3d config YAML. So we'll get into that quickly and then come back. So because in order to understand how a cluster creation is going on, so we need to jump into K3d config and say, so who particularly says, what is this K3d config? So who particularly says that I need a 2-node cluster or a 3-node cluster, and what are the configurations that it need to have? Where does the port listens to? Where do the cluster server LB listens to? All that particular information resides in K3d config YAML. That is this particular YAML, right? What's happening here? So it is kind of on a typical YAML file where you see this API version, kind, metadata, typical YAML configuration for a K3d version, which is alpha v1 alpha 5, and the name of it is Wins cluster. So you can just skim through this. I have written these comments as well, so that you make an understanding of, if at all, if you need to tweak around this IX, so you can go through it quickly and then make your be comfortable when making changes, right? So you see that this is where the control plane sits. So this is where your API server scheduler, and then since it is K3d, it makes use of SQLite DB. So this is how many numbers of control plane that you want. This is the configuration that you give here, and how many configurations of agent, the worker nodes, where the pods and kubelet sits. So that is where you give this. And what is the base image? So Rancher is an open source project where they have provided this K3s. So K3d is deployed on the source of K3s. I'm trying to pin this version because it is more stable, so that you always have a stable environment. And one particular note about this particular version is that it comes with Traefik 3.6 enabled, and gateway API you need to explicitly enable. How do we do it? We do something kind of Helm chart config. So here we go to the while we are trying to spin up, we kind of do a source injection here and place it in the destination, that is this particular destination, where during the deployment this particular volume will be created. This volume already exists as part of the deployment process. In this volume we are trying to make an ad hoc source and then push it into this YAML. So this will be picked up during the installation by K3d. So what is that we are trying to do? Nothing. We are just saying try to create a Traefik kube system, right? Which is basically Traefik. We are trying to install a Traefik, which is an ingress and gateway API controller out of the box given by this Rancher image, right? So, and it is, it is famous, right? So, and then on top of it, you enable a Kubernetes gateway. So gateway API is, if you guys know what is a gateway API, so before to this, one quick note about code space is that it has a timeout condition. You can literally get into the code space tab and try to increase the time, an idle time to 30 minutes, so that you could always come back and look at the status. It doesn't log you off at every 5 or 8 minutes or 10 minutes like that. So right, so I'm trying to check on that. So yeah, so I'll just run some random command here and see like what's happening within my cluster, right? So let's see that. So it may, yeah, so kubectl, right, get nodes. I'll not give any, yeah, get nodes. So you see this, so there are these 3 nodes which were part of the GUI there, then these are up and running as well. So let's get back. So now coming back to this, so yeah, gateway. What is gateway API? So gateway API is kind of a north to south traffic, which was previously taken care by Ingress due to its shortcomings of having bigger annotations and then being that multiple owners need to touch, developers need to touch a common configuration versus the cluster creators and your SRE teams. They need to, so all these shortcomings made they were long due, right? So they needed to be brought in sync, a kind of a protocol that everybody follows. The new way of having a north to south, that is not the east to west within the cluster communication traffic, but rather incoming and an outgoing traffic from outside the cluster to inside, and then the inside to outside. So that is taken care by the gateway. So imagine that it has a typical it is kind of a protocol that the modern K8s follows, Kubernetes follows. So that CRDs are pre-configured when you take the latest version of an K3d, which comes with Traefik 3.6. The CRDs are, if you enable, it is sufficient. I did some research upon this. So that is sufficient for it to be, the CRDs are pre-configured and are installed within your cluster, and the gateway API will be enabled. How do you check it? See, I did not install any CRDs here. You see this? There is no CRDs installed. So let's go to main cluster and see whether the CRDs are configured or not. So if you go to custom resources, you see this. I haven't done any CRDs. Let's see. There are, you will in the next page you would see that there are other ingress and all these routes. You see this ingress and all that. And typically you should also see a gateway. Where does the gateway, you see this gateway. So gateway class and gateway are pre-configured, and see this Traefik gateway is the default one. It's a default gateway. It's kind of a gateway that is provided by Traefik, but the only one shortcoming of this particular controller, this particular gateway API, is that it has only access to namespace within its same namespace. So what does that mean? That any routes that you create out of this, that is HTTP routes you create of it, it need to be sitting in the namespace this gateway exists, and the namespace that it exists is a kube system namespace. So you would know that, okay, nobody goes ahead and then creates it in the namespace where the gateway Traefik gateway is sitting, right? So in the kube system you would not typically do it. You would try to create your own application namespace, and then within that you try to create your applications, your resources, your K8s resources, right? So that we will get it in a short time. But yeah, you see that the CRDs are pre-configured. You also get a typical gateway, and then the gateway class. There is no HTTP route out of the box created. You have to create it. But yeah, this is how it gives. This is just to prove that the latest version of the Rancher has Traefik 3.6 plus version, and it comes with gateway API CRDs, and that CRDs gets deployed and picked up once you enable the Kubernetes enable to true, and keep it in this particular volume while it installs. That's all. Typically that is what is there in K3d config. And you are trying to configure 2 of the ports. As I said, 8080 was opened in the dev container, if you recall, was opened. Now that need to be mapped within the where does a K3d load balancer sit. So that is listening the K3d whole, the server LB, right? This is listening this server LV is listening at port 80. So we are trying to make that port wired up. And similarly goes with 9090 and 3090. This is a node port. You will, in short, in a while you will see that while we try to create a UI, we are trying to create at a node port which is at 3090, and we are trying to forward it to a port which is opened in Codespace at 9090. So that is what typically a port's configuration looks like. You can always look at this comments and then see. So I'm coming to this options. This is basically until and unless you go ahead and then create, there should be a timeout for this cluster. You need to wait up. So all this typical things. So you can basically modify this or extend. These comments should be able to help you out. Now quickly coming to what is there in init cluster, right? So we branched out from creation at the create K3d cluster create command and went into config, reading about the config and what it does, and so we just saw that. So now at the step 2 is to install a Headlamp UI as told before, right? So what we are trying to do is we are trying to use Helm capabilities here and adding the repo where the Headlamp is open source this. So we are just trying to take this open source repo, add it to your Helm repo charts, and then we are trying to install it. Right, install it, and you see this important stuff which was pre-configured in K3d. We are trying to say that this is the node port where it listens to, that is 3090, and then map it and forward it via this port which is at 9090. That is when you click this browse at open in browser, you would be able to see a nice little GUI over here. So that is how it is happening. The secret sauce is behind this init cluster UI automation SH. Right, now coming to this RBAC setup, which is, as I told before, this is a cluster wide permission that is needed, and one such permission is also used by your Headlamp. So that is a typical Headlamp setup. So you see that there is an SA account, that is service account, that is being created here, and then you are doing a role binding which is saying cluster admin. So you need to be very careful to turn this off into a public use, right? So you shouldn't. It's by default Codespace is protecting this by making it a private URL. Only you can access this. But if you make it public, what will happen is that you have given a cluster admin. So anybody, there will be typical web crawlers, right? So they will be able to understand this. I mean, if somebody gains access to this particular URL, a rare condition maybe, but then if they are able to do it, then your entire resource, your entire clusters might be compromised. So be careful upon that part. Otherwise, this is a typical Headlamp setup that you would find on their wiki, on their documentation, right? So once that's done, so what did we do? We created a cluster based on a pre-configuration. We installed an Headlamp UI, and for that Headlamp UI we created an RBAC access and then gave that token, which is nicely little settling over here. And then so in order to make it sit over there on a txt file, this is where that magic happens. So we based on this RBAC, we try to generate a private token which is of the duration 24 hours and token file. Let's say today you created this cluster, and tomorrow what happens is that you again want to have a same little cluster, so you would reserve this code space. So rather go ahead and then click on the code space icon over here and say that reserve this or bookmark this, so that this will not be marked by GitHub to be deleted. Right, so once you do this, so this instance will always be preserved, it will always be there, and tomorrow when you come and then try to log in, at that time again you will be prompted with a token screen. At that time again take these two little lines and then copy paste. That has been written in the readme documentation. If you see this, if you scroll down all the way down, so yeah, it is taking a little time. Usually Codespace at sometimes glitches out, but with the major time that it works clearly. So if you see this, these are the handy commands. So you see this, if you ever run out of or tokens for needed for this, you can just take this and then paste it again. A new set of keys will be created over here that you can copy paste over there, right, on the Headlamp. So that's what typically you see, that these are the three configurations that are there in the dev container, and that's done. That's what exactly happened within that 2-3 minutes of the setup which you saw, right, during this installation. You saw this, right? So all these are getting printed from where? It is getting printed from if you see this here, right, if you see this. So this is the place where the token generation and everything. So, and it has executed to the very last end of it successfully. That's why you're able to see the token for generation. So that what happened within that 2 to 3 minutes of time. Now let's quickly try to deploy a one sample app, which is Hello World, onto this breathing cluster, right? So let's see something being actioned out. So before to that, so let's go to README. Let's go through this README file. Let's see what all the things that we have covered so far. So yeah, so here I have written that it is a K3d cluster, which I have seen. So one thing is that you can directly click this and then get into Codespace, or if you are logged into GitHub like I am doing right now. So if you are logged into GitHub, so comma will detect will trigger the similar action that this click of a button will trigger. It is also similar to once you go this place and then say go ahead and then create a code space, everything. It is all similar. The simplest option would be if you are logged in, just come on this repo and say comma, you're bam. So you'll have a brand new code space that is being created, and then you'll be able to see this particular nodes. Where is that you are trying? Yeah, here. Right, so if you see this, these are the nodes that are part of this container. So again, so this is covered again, that is what has been written. And Headlamp UI is, as I told, head to port 8080, open in browser, and then this is what the cool browser that you would see. And as I told before, modern network gateway APIs are pre-enabled, and it comes with this Traefik gateway. Yet one more, the limitation of this is that anything that which you create as a new resource, right, HTTP route resource, it need to be sitting in basically in kube system, and all the resources further down your service and your deployment need to be happening at kube system only. So that is not a typical application environment that we will try to do in our real-time projects, right? So you need something which has a namespace access, which could be accessed outside the namespace. That is what we will do something in this. I'll quickly walk through this file. So if you go here in the example sections, you see that there is a one gateway YAML. So what this YAML does is it will create a new resource called as gateway. I have named it to Vince Code Gateway. You can name it to anything that you want. So if you go here, so these are the gateways. So if you go to this gateway class, these gateways. So yeah, typically error. So yeah, so you can just, it's a GitHub issue. So you can just, yeah, even if most of the things gets resolved by doing a hard refresh. So yeah, you see this, the Traefik gateway, it's over here, and we are trying to create one more of a similar thing, but with allowed routes to be accessible across the namespace, so that your app, your HTTP route app, can bind to this gateway and start getting the traffic right into your app, into your service. So that is what we will do. So in order to do that, just go ahead and then follow. What it does is you use the provided example for listener, just copy paste this particular thing. What it does is it is basically applying. So, and you need to allow this to copy paste from the clipboard and just say created. So if you get head back, you see this, it is very real time. So you see this Vince Code Gateway has been created, and it is just 8 seconds, right? So now coming back, yeah, so this has been created. What's the next process that we need to create? So let's see that. So you see this modern, yeah, this is done now. Vince Code Gateway is it's there. Now what we will do is we will try to, as I told before, we will try to simply run a Hello World demo app, and it should be up and running within 30 seconds. Let's do that quickly. So what we are trying to do, a quick walkthrough, is again, if you go to this all-in-one YAML, what's happening here, I have created a deployment, a typical deployment with this particular image where it says hello world latest is the tag that I am trying to refer, created by this open source guy. Right, it says what it will display, we will see at the very end of it, but a typical deployment you see, and then there is a typical service that exposes this deployment and the pods within it. And again, this is what important stuff is. So here I'm not trying to bind this to the one which we created here. So Vince Code Gateway is not I'm trying to bind with. I'm trying to bind with. One, it has been given as defaults to just to give you an example of where a typical resource, all your custom resources need to sit, if at all, if you are binding to this Traefik gateway which is there in the kube system. So what it does is, basically, how do you bind? You create an HTTP route resource and you place that HTTP route resource in kube system, and further down the service in the kube system, and then the deployment in the kube system, which is not the typical scenario, but for an example app this works literally fine. So yeah, that is what I'm trying to see, and then later on I will delete this just to show you that how it works, right? So yeah, HTTP route resource, it's a typical HTTP route, which if I just head on to the domain name, I should be able to see this hello world pod being deployed. So let's quickly create this. Let's go here and example all in YAML. So you see that the deployment has been created, the service has been created, and HTTP route has been created. So if you just go here, there was no HTTP route to begin with. Now if you go, there is one more route that is sitting over here. If you go to this map where it clearly gives that, if you see in an kube system YAML, you see that there is a web app deployment. We just did this. So yeah, we configured this. So this is a cool thing which I always I'm kind of a visual guy. I love that arrow marks and then block, how those are connected. If you are like me, then you can just make use of this. So yeah, so this is now typically up and running. What should happen next? Let's go through the documentation, check the running pods, see whether the pods are running. I mean, again, you can do it in the GUI, but it is more intuitive here. So let's go see this. You see that there are other pods as well that are running. Let's see them. Yeah, so you see this web app which we created. So I think what's the replica set that we have given? So two things are running. So 101, 2 pods are running over here. So right, how do you execute into it? Typical thing, you go to workloads, you go to pods, you select web app pod. You see this, you see the logs, right? So you see logs, the logs are up and running fine, and then you can execute into it. See, you see that LS works out, everything works out. So yeah, this is how you execute into any of the pods that have been so created by you, right? So now the web apps are up and running. What should happen next is that head to port 8080 and you should be able to greet with a message hello world. So this is 8080 which I was talking about. So this is a communication entry to your cluster. This 3 cluster, your 3 docker image, docker that are running, the containers that are running, which is a K3d cluster as a whole. You will be able to see which is exposed through HTTP route, and in turn through gateway API you should be able to see. Now the moment of truth. Let's click this. Yeah, done. Kubernetes. You see that the hello words, for some reason node name is not picking up over here, so just ignore it. You are able to get inside your pod and able to see this hello world message, right? So this is good. This is great. You have now just from zero, from Codespace, nothing, you have created a K3d cluster which looks like this, and you are able to deploy an app inside it and able to handshake within that. Not only handshake, you are able to work through your app, and then the app is able to run inside your pods, and it is able to do whatever the magic that it does, right? So good. I mean, you have to tap yourself back because you have ticked so long and then you're done all this great stuff. Now what you have to do is, one important thing is that since 8080 was pre-configured, if you see this init cluster, you have pre-configured. If you go into dev container, there is only one port that I have exposed within this. You can always extend this. This 8080 is always mapped to that particular pod application. So you need to delete this so that you start working and consuming your own, writing your own HTTP routes, consuming this particular, the one which has access to all the namespaces, right? Not the one with which the cubes which is sitting in kube system, right? So not the Traefik gateway, but use this, or one which you would try to create on your own by looking at the template like this. You can have any number of listeners that you want. You can create any number, n number of routes, or a catch-all route, whatever the route that you would like. So quickly, for all that to access, you need port 8080. Let's free up that port 8080 by deleting this thing, right? Deleting this app. So how do I do it? If you just go here, and say this is the same readme file which is accessible over here, the same from here, right? So if I just go and say delete it, so I should be able to delete it, right? So if you say cube cd, okay, sorry, I think I copied pasted it. So yeah, so you deleted the entire deployment, the service, and the HTTP route. So the typical one sits still over here, this Traefik gateway. You're not deleting it because it is out of the box. And this Vince Code gateway is something which we created so that we start expecting route. And if you just go ahead and then refresh it, nothing. So this port is literally vacant now. That HTTP route doesn't exist, so that's why you're unable to find it is 404 basically, right? So that's all. I think you deployed a hello world within 30 seconds while I demoed this, right? So yeah, so you're all done. So within 3-4 minutes you will be done with cluster deployment. You can test it out by doing these two little stuff, or if you are very well aware of it, then you can just optionally skip them as well. So yeah, basically why use this repo? As you've seen that it requires literally zero configuration. It uses you can zero config as in like you can just get to work, you can start working, you can start building using this cluster, right? Modern networking, because it uses a gateway API which is a successor to Ingress. It is Helm ready, it detects Helm. If you just go here and say Helm, right, so it detects it. You see this, you see everything that of Helm it detects. And you can also have enabled one more plugin, however it is not required, but yeah, the overall is that it is Helm ready, right? So you can just a template, you can download templates, you can install, you can upgrade the templates. Yeah, so then visual GUI, as I've given much more description upon it, that it is more kind of a visual thing that you could play around with. It's cool like that. And coming to that, it is free, it is deployed on a code space. Make sure that you have extended your timeout window so that you can like peacefully work on your stuff. There is nothing to be put on card. It is $10 free per month, so every month on month $10 is free. You can just play around it. There are other like Oracle Cloud and other Google's offering as well, but then that is only for 1 month, right? So but this one you can like month on month, it is free within if you are in $10 per month limit. So that's like 60 hours with 2-core machine. That's like 60 hours. So you see that it has been optimized for 2-core 8 GB. So you can like literally get a free cluster within this. You can conveniently develop, test CI/CD into this, do whatever that you want, learning, right? So yeah, so zero footprint. Yes, as I told, you can just literally head over here and then delete this. If you have broken the cluster, you can just go ahead and delete the cluster. Everything again fresh up starts within 3-4 minutes or 5 minutes max out. You will be having a new cluster ready, up and running. You can play it around. So no need to worry about whether I have broken, I have done something which is again I have to go and do an animal wrangling and try to clear up the mess and all that. Nothing, just go ahead, delete it freely, and then come back again and then do, just get to work, right? So it is fully open. As I told you before, nothing of this is I'm been picking. There is no voodoo or magic here that's happening. You can just go. It feels like a magic at first, but then if you get into the details of dev container, init cluster, and these AMLs, you would find out that everything over here is written in an IAC manner. So you can like literally extend it, modify this, and then you can make use of this, right? So what I have been doing is that before making all this out there, making it out public as a template, I've been building my own services, backend services, and trying to deploy onto this cluster. Whenever I have a K8 cluster in need, I would use this. I'm dogfooding. I'm drinking my own champagne right here. So I'm trying to get this cluster up and running, trying to deploy through Helm charts into this cluster, trying to port forward within out of code space, and then trying to consume from my Vercel hosted front end or something of that sort. So yeah, and what average time that I have found out is this, which I have shared the pic. And how do you get to that? You see this, even now, right now it is at 3 gigs, and around 15 to 30% at max. You could see that the core utilization has been. And couple of handy commands before we depart. That K3d cluster, how do we stop any typical, if you have been working with, let's clear this off. If you have been working with K3d, right, so you would see these are the handy commands that you will typically get out of kind of K3d outsource this. So right, so K3d cluster stop will literally stop all these containers, right? It'll one-on-one, it'll keep on stopping this container. You can also go here and right click and say stop one by one, or you can restart. At some time what happens is that this glitches out. Even if I go to this, it keeps on reloading, nothing appears in the GUI or nothing, you will not be able to hit your endpoints. At that time, what you do is typically you just go here and then say restart. Basically all your endpoints are accompanied with this server LB, so you can just do a restart on this server LB. That should resolve your issue. Or otherwise server, you do the restart. If nothing works, again you go to this. If cluster or endpoints are frozen, you just do a restart on the entire all these 3 nodes. It should be up and running, right? You should be unfrozen by that point. So now how do you stop the cluster? You just say K3d cluster stop, and then it stops this cluster. You see one by one it goes to red while it does. So how do you start it back? So K3d cluster start, again a simple command, it will do it back. And then if you are frozen, all I told was this, right? So now this is something which we did initially, right? So if token expires and all that, this is what you do. Coming back now, whether the clusters have successfully, those are stopped, you see that they have went into red. So now to start it back, again you give a start command, which is like integrated one, which starts everything up, or one by one you can start it up. I would rather recommend you to just do a K3d start. And again, if you are frozen, do this docker restart selectively. Yep, that's all. You see this? If you see that this is a fair work, try to star this repo. That will help me, give me confidence of doing these things more and more, right? You support the project, you tag me along. You see that I have given my LinkedIn tag as well. So yeah, you basically go here and then star the repo. That gives me a kind of a tap on the back. It is something which is an open information that's out there. I try to collect it to a one repo and try to make it as much as automated as possible, so that I try to do it for my own project. I thought, okay, this could be a template on its own, then I tried making this up. So if you want to support this project, go ahead, do this stuff, and finally contribute and support. If you have if you find any issues, if you try glitching it out, try doing your own self troubleshooting first. That's how you will learn. Try to follow these commands. If not, at any point in time, go ahead. There are so many resources out there. Even at the end, let's say that it did not work out, so go ahead and rise up an issue. Or if you are an open source person like me, then just go ahead and then say rise up a PR if you know the solution, right? So rise up a PR onto this. I will review your PR and try to merge, and we can together make this happen. Right? So yeah, thanks pretty much for sticking so long. And similarly goes with the other Minikube cluster. The only difference between a K3d cluster, I recommend K3d cluster because it is a true multi-node capacity. You could practice or see the pod affinities to a particular nodes and all that. But whereas in a Minikube, it is it is very resource intensive. But you get a full-blown K8s environment. Again, I will try to make one more video going through this once more, but then that's what difference between this template and the one with Minikube template. More on that later on probably. But yeah, thank you. Go ahead and give it a spin. That's how I would say. Thanks. Cheers.